Hello there, and welcome to the last video in this series. Today, we're going to learn about the programmable brick. We're going to learn two interesting things that we can do with it. The first is to sense how far the infrared beacon/remote is. And the second is to make the robot play sounds and to make it essentially sing. In this case, we will make it sing Twinkle Twinkle. Now we're going to learn how to find the proximity of the infrared beacon or remote. So the first thing we need to do is to select the infrared sensor block over here and set it to measure the proximity. The next thing we want to do is to select a display block and place it here. We're going to change it from image to text and to pixels. On the display block we have 5 different settings. The first one is if the screen is clear or not. The next one is how far it is from the corner of the screen on a horizontal axis, and the next one is how far it is from the corner on a vertical axis. The next one is the color, and the last one is the font size. There are only 3 font sizes. We're going to go with the largest. The next thing we want to do is to change the parameters of how the display receives its data. So we're going to select wired, and then we're going to connect a data wire to here. What this essentially does is any data from the infrared sensor on how far the remote beacon is will transfer along the data wire to the display and should display it on the screen. So we're going to change the X and Y values to make it sort of in the middle as such. And when we play the function, what should happen is that the infrared sensor will sense how far the infrared beacon or remote is, then give the value to the display, and we should have our reading. Now, if we want to have this going on continuously, we of course need to place it inside a loop. So what we're going to do is place it inside of this loop. We're going to keep it on infinite or unlimited so that the infrared sensor is always checking its environment and its surroundings. Now, let's test it out. Now, let's test it out. The next part of this video will focus around the programmable brick's ability to play sounds. So, here we have the sound block, and in the sound block we can play a variety of different sounds. We can play tones and we can play notes. We can also play preset files from Lego. These come under project sounds over here, and then Lego sound files. We've got these different subfolders such as numbers, movements, mechanical, information, expressions, etc. We're going to stick with the communication, and these are simple phrases such as hello, good job, goodbye. So we're going to test this out.
Hello.
There's our hello. This is our goodbye.
Goodbye.
This is good job.
Good job.
Can all be used at the end of a function if you want your robot to play sound after, let's say, it's moved. The next thing we can do is we can get the brick to play different tones in terms of frequency in hertz. So each of these frequencies account for a different note. We'll be going into this later. The last thing you can do is play different notes individually. So for example, this is an A5, F5, and so on. We can change the seconds or the duration that the sound plays for, as well as the volume. This last one is how many times or by which parameters the sound plays. You can have it play once a program has been completed, you can have it play once, or you can have it play on repeat. Here we have the code that I've built for the brick to be able to sing or play Twinkle Twinkle Little Star. As you can see, I've named each loop after its note that it represents, and I've used play tone on the sound block. I've used each frequency for each note, so as you can see, the first note is C, which is 261.63 Hertz. I've set the seconds to 0.5, as that's the beat that the song follows. I've set the volume to around 60, so it's not too loud. And I've set the loop count to 2, as the way the song goes, the note is played twice before it moves on to the next one. Now, for majority of the notes within this song, or function, it follows the same sort of parameters. The loop will always be 2, and the duration will be 0.5, as well as the volume. The only thing that varies is the note, or in this case, the frequency. So for G, I have 783.9. And for A, I have 880 Hertz, and so on. The first change over here, in the song, there's also a rest after this note. Therefore, we have a wait for 0.5 seconds. Then we move on to F, which follows the same structure as the first 3 notes. Then E, then D, and we end off the song with a single C note. Now, let's see what it sounds like.